Hello, good afternoon, good morning, and good evening. This is the session called Debate, Is Connectivity a Deal Breaker to Factory 4.0 Success? I'm Cristina Paziura. I'm working with a GSMA Intelligence as an analyst covering IoT and enterprise as part of the GSMA. And I'm very glad to be joined today by our speakers, Bernd, Sundar, Alper. So guys, would you like to introduce yourselves and tell us about your involvement with the topic, so Connectivity Factory 4.0?
Yeah, I can start if you like. My name is Bernd Kercher. I've worked various years with Festo. We are a supplier of automation components and general field of automation. And as a part of the advanced development, I always had the job to look into new technology and also in new trends for connectivity. And one of my heart and soul topics for the last years was wireless connectivity, dealing with a technology called IO-Link Wireless that we brought to, that is just on the way to the IEC standardization, but of course also 5G is something you have to deal with as an advanced development department. And we are about to sample individual experiences with this technology. And a good network that I'm part of is the 5G ACIA. This is a good platform for small OTs that we are to connect under each other and understand the ecosystem around 5G, but also bring up a certain momentum to bring impulses for standardization together with ICT companies into 3GPP, which is an organization that's much too large for companies like ours. Thank you so much for the introduction.
Awesome. I can go next. This is Sundar Somasundaram. I head up the fleet and industrial verticals here at Core Wireless. Been in IoT for 6+ years. Previously with AT&T, heading up their global sales teams for IoT applications. So looking forward to this panel discussion and the interaction. Thank you.
Thank you, Kristina. This is Alper again. I'm the Vice Chair of the Board and Chair of the Technical Committee in the LoRa Alliance. I'm also the VP of Advanced Technology Development and Actility. LoRa Alliance is in charge of building the LoRaWAN technology. LoRaWAN is an unlicensed band LPWAN connectivity technology. It does apply to numerous different verticals, including smart industry and manufacturing as well. So in addition to being involved in the technology development, also with Actility, we build core network systems for the LoRaWAN networks, both for public operators and also enterprises, again, including smart factories and manufacturing and similar use cases.
This is great. I think we have some great experience to draw some insights from here. So let's set the scene as for connectivity in factories in manufacturing. So based on the studies that we see, and we also do at GSMA Intelligence, obviously the landscape is really diverse, but there is a lot of legacy technologies, as we call them, a lot of fixed connectivity, and obviously a variety of wireless technologies. Some of them are beginning to take off, some new ones. Some of them we assume that will be there for a long time to come. What is it, in your view, how does this landscape of connectivity in manufacturing looks like today? And based on your experience, what is working well? Where are the challenges? Shall we start in a different order? So Alper.
Sure. So when we look at the manufacturing and how they have been adopting wireless communication technologies, we see they are slowly cutting the cords, the cable. They do have automation, And to most extent, it's using wired technologies, and the wireless has been moving in. But the whole industry has been adopting the wireless communication technologies pretty cautiously. And that is because they have to maintain their ongoing operations, and they cannot stop everything and then experiment with the technologies and then restart again. It's like changing the engine of a flying airplane. And what we see is overall, there are various different wireless communication technologies being geared towards the manufacturing, and there's no one size that fits all. There are different technologies. We see a mix of cellular, Wi-Fi, and LoRaWAN technologies moving into the manufacturing sites. And we cannot also expect running sites to get connected overnight, and all this adoption will have to go incremental. And it all starts by understanding the customer needs and getting detailed requirements. Otherwise, all too often the expectations aren't met if the two sides do not fully understand each other. So at this point, it's really hard to automate the onboarding, and it's not fully plug and play. And there's a boutique activity that needs to be carried out, understanding the requirements and the solutions. So that's where we see we are at the moment.
Yeah, I can go next. So today, based on what we see with our customers, most of the manufacturing customers have a partially wired systems, and a lot of it is actually, legacy. We haven't really talked to customers that have actively rewiring their plants with Ethernet, because we've actually seen a shift to cellular and also some Wi-Fi technologies. Based on what we've seen, at least with Wi-Fi, a lot of customers are still on the fence, especially when it comes to security and how they're leveraging it. So cellular is definitely emerging as a standard. And I can tell you, one is the convenience of use, which is really driving that. But the second one is really they're increasingly living in a world of these sensors that sit on these machines. Now, you look at a standard, compressor or any sort of machine that's connected to a PLC in a factory. Customers want 6 or 7 sensors on these things measuring different aspects, right? And now they're realizing that, well, now I need a gateway. Well, that gateway needs to talk to some other sort of a hub. So it's increasingly kind of pushing them towards that wireless world. So I think we'll still obviously have Ethernet, just like how we have it, in our homes and cities and things like that. But then everything else from an edge in perspective is increasingly going to be wireless.
From our OT operator side, we see currently most of the factories connected by cables. Of course, as Sander already outlined, most is a kind of Ethernet. Maybe you can call it Profinet in Europe or something else, but this is comparable. And wireless, I think, is mostly only used at the moment when you have pain points like breaking cables or other moving parts that should be connected. And companies are about to look into the new possibilities that you achieve with wireless connectivity. For example, what Sander just outlined, the condition monitoring, something where the level is relatively low. The fruits are hanging also relatively low, and you can gain some benefit when it comes to change the core connectivity, replacing the things that are vital for reliability. Then customers are much more conscious, because this is, for example, was one of the interesting discussion when getting in touch with mobile operators. The reliability demands, for example, in a factory, are losing a telegram once in a year or something like that. That was a completely new discussion for other participants. So I think we are just in the beginning of the change where the the participating communities are understanding the benefits that you can achieve afterwards.
So I think there is some consensus that wireless is picking up. There can be a discussion about how fast, is it incremental, is it easy to like reconfigure a factory's networking infrastructure. Probably it's not. Alper mentioned it's a bit like replacing an engine on a plane. So what do you believe are the drivers? Bernd, you mentioned of low-hanging fruits. So that sounds like a use case discussion. Is it use case dependent? Is it something else? So what are the drivers for this, like wireless connectivity, slowly or less slowly picking up?
Yeah, what I've learned from my production colleagues is that when you are able to increase in various cases the output of your production, then you get good arguments for new technologies, and that means reliability of the production. So something like predictive maintenance, if you are looking into your drives and watching them and get information for service before you get a failure, then this is a case where you can get acceptance. Or if you have other monitoring applications, for example, tracking your equipment where it is running around, and this you always have the challenge that somebody in the production doesn't want to have a fancy technology to deal with. That is more for the developing colleagues. But you always have to give real hard numbers where you get a financial benefit in the plant. Then you are in a good way. And I think this huge IoT discussion with big customers that want to get more information, and you have to this life cycle management, and this is also might be one of the next drivers to build up a wireless infrastructure, that you are able to share the information about your components or the products in a bigger ecosystem than in existing plants. That might be also a driver.
That's very interesting. So it can develop also to something bigger. So to rethink about manufacturing, about how manufacturing processes are done. So Sander, Alper, what are your thoughts about drivers for wireless technologies in general? So let's start in general, then we can zoom in the different types. So Sander.
Yeah. So, I think Bernd made some great points in terms of predictive maintenance and the analytics. From our perspective, what we're seeing as the biggest driver for wireless is a number of, a significant portion of the manufacturing is actually driven by OEMs, right? And these OEMs make machinery that sits in their customer premises. When they come to us, they really are looking for a solution that they can just ship as part of the machine that they're manufacturing, that's actually going to sit in their customers' premises, and they don't want to necessarily, work with the local wired infrastructure of that company's IT, open up holes in their firewall, or ask them to install a router and configure it for their Wi-Fi. Honestly, it's for them just the aspect of having a box that is already plugged into their machinery. As soon as the machinery is set up, and it's powered on, the cellular router fires up and it starts sending the data, and allows this customer then to remotely manage this asset without having to do anything at all, right, with the customer's infrastructure or their IT teams, is honestly driving a lot of the benefits for them already, right? In addition, now they have the option to obviously add sensors or create other things, data elements that they can then push up into the cloud, right? So we're seeing actually that whole sort of ease of connecting these machines out in the field is one of the biggest drivers today for wirelessly connecting these assets via cellular.
Alper?
Right. Yeah, I'd like to echo some of the examples that were given by Bernd and Sundar and maybe add some more to them. So clearly, well, there are several use cases that we see there is market traction, such as tracking location of workers and equipment, which obviously cannot happen or work with a cable attached to them. So that's definitely that requires a wireless technology. So tracking location of such assets, these are essential for the safety of the workers and the efficient utilization of resources. And through that, manufacturing sites are able to have great savings and become more worker friendly. And we also see a lot of predictive maintenance solutions coming into the market using vibration sensors, image sensors, running the AI, the machine learning on the end device and only transmitting the outcome. And such sensors have also accelerated thanks to the introduction of solid wireless communication technologies. They could have been developed in the past, but that they would have required laying a wire all the way to the equipment, and that was presenting an extra hurdle for the adoption. Now that the wire is out of the picture, we see acceleration behind building such sensors, and they've been rapidly being productized by several vendors. And other things like monitoring the level of water, waste, having occupancy sensors, air quality sensors, again, having a habitable environment, and also to protect the environment outside manufacturing sites as well. Pressure sensors to detect before a pipe bursts, and having contact sensors for safety and security and all that. So we see a rapid adoption of such sensors, and the whole market is pretty open for hundreds of different types of sensors to enter the scene. And as for the reasons we've talked earlier, that's going to take a little bit of time, but we already see automation entering into the manufacturing sites.
So if I can summarize a bit, the drivers that you see is easiness, of course, of operating the machines themselves in some cases. It can be obviously new use cases, so not possible before. And also back to Bernd's point, it can be also part of something bigger, so to sort of enable the networking infrastructure for the factory of the future.
Perhaps one short remark that we've forgotten, or at least I, is
sure.
Talking about energy efficiency. These green arguments require also some ad hoc, a lot of additional ad hoc sensors to be integrated into an existing plant, for example. And that's where wireless technologies also bring up real benefit for the installation of such energy monitoring or energy optimization systems. Sorry for interrupting.
No, absolutely. Well, actually, to your point, Bernd, many companies who are operating factories, they have complied. They need to be compliant with sustainability targets, and we all know that IoT sensors, these smart technologies, can be conducive to it. So let's take a step a few years back, right? So with the start of IoT, so Sander and Alper, I know that you are, at least your companies are very like IoT native companies, and they have been having this involvement probably in the last 10 years or so. Mm-hmm. So how have you been following this story? Are you happy with installations and deployments in factories of IoT, because this was new for manufacturers, for factories. So what is like your experience now in retrospect? So Sander.
Yeah, I think you hit upon a great point there, right? So there's a great sort of interest in driving sort of Industry 4.0 technologies. But there's also some big challenges. Traditionally, a lot of manufacturers, they've been really smart about, how their machineries work. Some of these engineers are really great at, identifying all the different tags and locally, managing them and things like that, right? When it comes to really, okay, now how do we get this into the cloud? How do we start building a digital twin of this in the cloud? There's been a lot of focus on the cloud, and there's not been enough attention that's been paid at the edge. But without that happening, you're really not going to get anything in the cloud, right? So we've started now seeing a shift in companies, and they're starting to focus more on that edge. And absolutely, some of the things that these companies and these manufacturing companies need help with is things like site survey, is things like installation, is also things like, so for example, when we ship our routers to customers, we have to actually ship it at the DIN rail kit that they can just attach, they can screw it in. It actually comes with the screws and the mounting bracket and all of those things, right? Because at the end of the day, if you had to make it so simple that they can just take it out of the box, screw it and plug the wire and turn it on, and it's working, right? So doing that site survey, doing that sort of installation, especially when it comes to things like private networks. But if it's cellular and if it's for things like building out digital twins, it has to work out of the box, and that's where we're seeing a lot of these customers need help with. And less so in terms of, okay, building out the digital twin, right? That's going to come down the line after they collect enough amount of data that they can actually start building out some models and identifying what their data is telling them about their machines.
Yeah, well, when we look at the manufacturing side of Factor, we see like tremendous amounts of use cases we can jump on and then make a difference. The whole place is like so ripe for disruption, but then jumping on every one of them all at once, that's certainly a great recipe for nothing to work, in the sense that it's such a big, it's like boiling the ocean. So what we tend to do is to look at the immediate pain points. For example, say we're talking about a predictive maintenance to predict when an equipment will fail, but forget about trying to predict when it will fail. Monitoring its running conditions, even that is not being done properly. How the running time of that machine is measured today. Usually there's no way to measure it at the moment. So by simply using sensors to track when the equipment starts running and when it stops, and reporting that makes a huge difference. And then on one side, identifying immediate pain points, and then the other key ingredient is to be as least intrusive as possible. So trying to change multiple things at the same time, once again, it's a showstopper. Instead, there should be a incremental way of entering the scene. For example, Modbus is widely used at such sites. It's used over wired connectivity. So a good recipe that we have been seeing the market has a pretty well acceptance rate is to migrate from Modbus over wired connection to Modbus over LoRaWAN. So still keeping the Modbus and the whole infrastructure, the software running behind that, just changing the wires with the LoRaWAN connectivity. So these are the two things that we see has been pretty helpful in gaining traction. And once the traction is in place, the rest of the use cases will fall into place. It's just a matter of time.
I'd like to take the opportunity of some comments you made. Sander, you mentioned about making it easy, making it like plug and play almost. So in the analyst world, all of these challenges, we call these like challenges around OT, operational technology, IT, information technology, integration. Mm-hmm. And we see that at least in manufacturing, again, based on market research, maybe more than half manufacturers say that with IoT, so adopting IoT, is a real challenge with IT and OT integration. So before we get into the conversation about 5G and come to you, Bernd, so I'd like to ask you two again. So do you agree, so Sander and Alper, do you agree that this is a continuous challenge, because we have been discussing this, I don't know, for more than 5 years, IT, OT integration with IoT. And is it something like more intense in manufacturing compared to other verticals? So Sander, you have experience in fleet management, if I'm not mistaken, and you, Alper, also in other verticals. So what is your view on these two aspects?
It's a really good question. So, and I think you hit the nail on the head when you sort of compared it to fleet management, right? Fleet management has been one of the earliest verticals to adopt IoT. So I'll tell you why IT and OT is much more of a challenge in manufacturing, not because of the technology. Fleet management as a vertical started adopting, cloud-based technologies, wireless technologies at a very early point, and they were forced to do that, right? You have to have wireless capable devices. You can't have other technologies, wireless technologies working there, because of the fact that the nature of the beast is that these vehicles are mobile, right? I think we are at the early stages of that happening in manufacturing. We're seeing more and more of these manufacturing shift their workloads to the cloud. If you continue to do sort of local data integration with these IT and OT systems, you're always going to have issues just in terms of that integration in itself and the complexity that it brings. But as these IT workloads start moving up into the cloud, and as these sort of manufacturing digital twins also move up to the cloud, we're going to see that sort of integration become more and more simple, more and more standards-based, versus it being, more proprietary software. So we're seeing increasingly a lot of manufacturers that used to have connected machines sending data to their local premises stop doing that. They're moving everything, at least the most important aspects of that data up into the cloud and starting to do the integration there. So I think it's absolutely a challenge today, and it remains a challenge, I would say, in fact, for more than 90% of these manufacturers. But I think we'll see that over the next few years, as they adopt the cloud more, you're going to see that drop pretty significantly.
Yeah, just to add to Sundar's points, I mean, another element is the mission critical nature of the environment. A lot of the processes running in manufacturing are running on real time and mission critical. As such, the requirements are higher. And secondly, they tend to be really complex systems that are built over time. And sometimes, we might even run into places where nobody knows how things are really working, so they're really afraid to stop them and then interfere with them. So for those two reasons, in addition to what Sundar has pointed out, I think the manufacturing has been a relatively more challenging vertical compared to logistics, smart agriculture, smart buildings, things like that.
If you agree, I could also make some short remarks on my experience in this context, because we had also discussions with our IT department on Festo, and we got a relatively relaxed relation on kind of service level agreements. As soon as our IT department is seeing a business case, and then they are quite happy to implement it. But it is always this discussion on the cost side. But we didn't experience such a huge gap between IT and OT. The IT is also discussing on the same level, more in a role of a service provider, and the OTs are the responsible for the running production. But they are, I experienced it that they are interacting on a relaxed business level, and nobody refuses to do anything to the other sphere. Just this is as an addition.
Thanks for this, Bernd. Yes, it makes sense, and I guess every company can also be different. All right, so Let's now move to a very hot topic. Let's move to the role of cellular and emerging 5G for manufacturing factory-based applications. So Bernd, I know that you have your very own view of things. Do you think 5G in any flavor, like public 5G, private 5G, hybrid 5G, is this something that industrial and manufacturing people and the ecosystem should know more about? Is there like something promising for them?
Yeah, I think when you look at the media, there's promised almost everything. I would say that you can solve everything, but the only thing that helps is to deal with the technology. It's not sufficient to look into papers or in the social media and hope afterwards you will get solved every problem. The only thing that is beneficial is to pick out concrete use cases and discuss them and also talk about the costs, of course. And then I think that 5G is important and is relevant, and you can most of the problems you will need 5G, but I think there is a level below 5G, and that gives a lot of application for other technologies. For example, to collect sensor information and bring it to a 5G gateway makes other wireless technology also useful, because you get a good solution without a licensed spectrum, for example, or something like that. And I think when you look at wireless connectivity, then you should look not only at 5G. That would be is my current consensus.
Sorry, I think I was on mute. So thanks for this, Bernd. I will address the similar question to both you, Sander, and Alper. So Alper, I believe you can bring in also the LoRa aspect to this. And since we have also received some questions from the audience, I might as well bring that up. So we have a question: where do you see LoRa benefits in a 5G network world? And obviously, we can make this more specific to manufacturing and industrial applications.
Sure. Yeah. So as we've been talking about the manufacturing use cases, there's a very vast array of different use cases. Some of those use cases require real-time communication, or they require a large amount of data being pushed in the order of like megabytes or gigabytes. So for those type of applications, clearly cellular technology coming from 3GPP, operating over a licensed band, that's its strength for such use cases. And then that's what we call a mission critical IoT. So there's this terminology. And then there's the massive IoT use case where the devices, they need to run on battery, so they need to consume less amount of energy, and they have little amount of data to send, in the order of at most kilobytes a day, maybe tens of frames a day they need to transmit. And real-time communication is not a must, and that's where LoRaWAN comes into the picture to address the massive IoT use case. So in practically in every vertical, not only in manufacturing, there are use cases that requires one type or the other type of connectivity, and some of the use cases can use either or. And the picture is pretty similar to what we had with 3G and Wi-Fi back in year 2000. Back then, people thought only one would address the whole market and the other was not needed. But fast forward 6 or 7 years, it became clear that these technologies are complementary, and the use is determined on a case-by-case basis. And we see the same is already happening at the manufacturing side with the cellular technologies and LoRaWAN, and also in other verticals as well.
Sander, how excited are you for 5G in factories? And there is also a question from the audience that I think is very relevant. Given also your experience with Core and AT&T, so what is the difference for a customer with working with an MVNO like Core and with working with an MNO, so mobile network operator?
Yeah, so I think there's two questions there. So I'll answer both of them. In terms of excitement for 5G, absolutely, right. There's huge benefits that from a manufacturing perspective, just in terms of latency, in terms of connection density, in terms of the additional security that 5G provides. That I think it would be if manufacturers ignored it, it would not be very wise on their part. That being said, we're still sort of in the early adoption cycles for 5G. So I think for devices to catch up to the ecosystem, even public 5G is still sort of developing. So I think we're still sort of in the early part of that adoption cycle. But private 5G, we're definitely seeing more and more, of those sort of installations happening. Again, not necessarily from a production perspective, but manufacturers are obviously curious to see how this is going to evolve. Obviously, investing overall in that sort of cellular ecosystem is going to provide them benefits for years down the line, right? So absolutely excited about 5Gs, but again, still early on in that cycle. In terms of working with Core as compared to the MNOs, at Core, we're not just about connectivity. In fact, our sort of go-to-market is connectivity solutions and analytics. So for each of the verticals, we have pre-configured solutions, like what I just explained for industrial. We have a pre-configured solution with routers, with connectivity, with the sensors, and with the cloud technology all bundled in, so that our mission is to make IoT super simple. So any one of our customers in these verticals can just deploy these pre-configured solutions and have it up and ready to go, right? So that I would say, as compared to the MNOs who are really still focused on the transport technology. So I would say that's sort of the biggest difference between Core and the MNOs.
That's a good point. So Bernd, looking at private cellular networks, well, obviously 5G is coming after 4G. Private cellular existed with 4G LTE as well. And again, coming from the perspective of manufacturers and the decision-making process, so how can they navigate all of these decisions about types of connectivity? What are the advantages of private cellular? Is it better to use LTE, 5G, LoRa for IoT? So what is your perspective? Is that pain points still in there? What is needed for things to accelerate and be done better?
I think that the big advantage of 5G on premise or 5G on edge or a private network is that you get some technical parameters that were not possible before. That this is low latency in the region to 1 millisecond. That is one of the big promises of 5G in general. And this combined with a higher reliability, when you have use cases that require these technical features, then private network is a perfect solution. And the second aspect is in privacy or security. That's what we learned from the big OEMs. If you want to really keep your data, your information private and share it not in a public media, then a private network is also a good solution. But other way around, not all applications will require private network in industrial applications. A lot is also possible in the public spectrum.
Thank you for this. So we are approaching the end of this conversation. We have been having some questions about what is like a step guide as for choosing connectivity, and we shouldn't really omit to, ask the future question. So if you can, each one of you can give like a quick 2-3 tips to people to decide on things, on how to start on things. And then your own perspective as for what we will be talking about if we were having this conversation in 5 years' time. So Alper, you can start.
Yeah, so what I would say is first there's have to be a really long checklist of features. It's so long that I wouldn't take the next minute going over that. It won't fit in there. All the technical features. So that's number one thing to do. Secondly, to look at the references. Has anyone else used that technology in a similar setting? And third, even if everything checks in the checklist and even if there's references, everyone's own environment is so unique. You need to do a POC to see if it really works the way it's been claimed and referenced elsewhere. Only after then you can be sure that this technology is what solves your problem. It's not a trivial task, but at the end, it's an investment worth. So those are the 3 main steps.
Yes.
I would recommend.
And unfortunately, we will have to break up. So this is a great event, superbly organized. So let's stick to timelines. Thanks everyone for being with us and for sharing with the audience your insights. Looking forward to meeting you again.
Thank you so much.
Thank you.
Really
Thanks
appreciate
for the
it.
discussion.